Hi, my name's Piper, and this is my physics lab on constant velocity. So here's a table of contents. First I'll have the introduction, the physics, the procedure, the data, potential errors, and the questions. So the purpose of this lab is to demonstrate the principles of Newton's second law and apply them to the real world. The lab accomplishes this by comparing a model of the predicted position of an object rolling to the position of the actual object rolling. The object is traveling at a constant velocity. This lab compares the position time graphs of the model and the actual object. The actual object travels less distance than in the model because of air resistance and friction. So this lab is about Newton's second law, which is the momentum principle. Newton's second law relates the net interaction between system and surroundings to the observed motion of the system. When there is not enough force on a system, the change in momentum is zero, and therefore the velocity stays constant. The velocity update formula tells us that if the net force on the object is zero, then the velocity will not change. The momentum update formula tells us that if the net force on the object is zero, then the momentum will not change. And here's the velocity update formula. So the procedure is to record an object rolling along a surface, then upload the video to Tracker and track the position of the object by pinpointing the center of mass for each frame at set time periods. Then I used the starter code on GlowScript to create a computational model of the object's motion. Then I made a spreadsheet using the position and time of the actual object and of the model. And then with that, I made a position versus time graph using the two lines on the spreadsheet. And I compared the lines and drew conclusions for the experiment. So here's the video. So the video of the object begins after the object has left my hand, so there's no external force acting on it, except for friction and air resistance. But the object should move at a constant velocity, and the system is the object, and the surroundings is everything else. So the object started at 0, its initial velocity was 0.117 meters per second, and it went for a total time of 1.3 seconds. And so here's the graph with the data from the actual object rolling, and it looks linear, but it isn't exactly because the object slows down over time because of friction. And here's where I calculated the initial velocity. So then I went to GlowScript and put the information in to get the computational model. So the net force is 0 because the object is moving at a constant velocity. Change in t is 1 divided by 30, which I got from the tracker, where it said that the frames per second was 30. And then the total time was 1.3 seconds, and I used the velocity update formula and the position update formula. So here we can see that the actual one did not go as far as the model because of friction and air resistance. So potential errors in this experiment were that I may not have tracked the object accurately on Tracker by placing center of mass wrong, and also there were friction and air resistance, which meant the net force was not actually 0. Some questions are, what if plus x and minus x were interchanged and it would just give a negative slope instead of a positive slope? And then, is it possible to say how many forces are added together to give a 0 net force? And there are forces such as air resistance and friction, which did not give a net force of 0 in the x direction. And there's no net force. And there is a net force of 0 in the y direction. And that's it.